Okay, now we're going to talk about aldehydes and ketones. The one thing that aldehydes and ketones have in common is this carbon-oxygen double bond. When we're looking at the periodic table, we know that fluorine is the most electronegative element, and as you get closer to fluorine, the electronegativity increases. Here's oxygen right next to fluorine, and here's carbon. Oxygen is much closer to fluorine than carbon. That's making oxygen more electronegative, which means that the electrons are wanting to drift towards oxygen. That's why you have this negative sign here and this positive sign here. The electrons are drifting from the carbon towards the oxygen, which is giving it a partially negative charge. Remember, this means partially negative when you see it written, which is giving this one a partially positive sign. That is giving it an area where it can actually interact with water, because remember, water also has oxygen with a partially negative and a partially positive side. So the hydrogen from the water is going to interact with the oxygen. So when you're arranging it, the hydrogen is going to be attracted to it, forming hydrogen bonds. And we're going to talk about that a little bit later in more detail. So both aldehydes and ketones have this carbon-oxygen double bond. The difference between the two is that ketones are surrounded, that carbon-oxygen double bond is surrounded by carbons, whereas the aldehyde has to have a hydrogen at least one side. Now, one thing to keep in mind then, when you're looking at a carbon chain, is that an aldehyde will always be at the end. And the reason for that is because of this hydrogen. So if you draw a bunch of carbons, if you want it to be an aldehyde, you have to put it here because the last one has to be a hydrogen. If you put it in the middle, like a ketone, if you put it between carbons, there's no place down on this carbon here to put a hydrogen. It's already connected to two other carbons, and there's the 4 bonds, the double bond and the 2 single bonds to carbon. That's making it so ketones have to be in the middle somewhere. And aldehydes always have to be at the end. Now when we're naming aldehydes, we're going to name it just like you would with the alcohols like we did before, but instead of having an OL, alcohol ends in an OL. Aldehydes end in AL. Be careful of not confusing those because they're so similar. These here are just memorization because they are the common names, whereas the IUPAC names are the systematic. And we're going to have a couple examples of these. For instance, the common name is formaldehyde. That's what you would have to memorize. But if we look at it as a IUPAC, the systematic name, we see that there's one carbon. Well, one carbon is meth. If it was a actual hydrocarbon, be methane. ANE, because they're all single bonds. Take off that E at the end, and you replace it with AL. That's where we get methane. Take off the E, put in the AL to be methanol. For 2 carbons, it's usually ethane. Remove that E at the end. Replace it with an AL is ethanol. Now, if it was the common name, it would be acetaldehyde. And that's just some memorization. Whereas the IUPACs are things that you can relate to what you already know, because it's a systematic naming. Notice in each example of these aldehydes, the actual aldehyde is at the end because it has to have a hydrogen connected to it. And then we have benzaldehyde. So if you have a benzene group with an aldehyde on it, you're going to end the word in benzaldehyde. Alright, so let's look at some namings. Notice it's at the end, so it's an aldehyde. We have 1, 2, 3, 4, 5 carbons in the longest chain. That gives us pentane. We have a double bond of oxygen and H. Now, because of the fact that aldehydes are always at the end, you don't actually have to put a number as to where the oxygen is. So we just change the E to an AL, pentanal. But we do need to number our substituents, which is methyl. So we always start counting on the side that's closest to the oxygen. 1, 2. So on the second carbon, there's a methyl group of pentanal. Alright, let's look over here. This is a benzene ring. It's also written like this. This is the same thing as this. They mean the exact same thing. That's the aldehyde. That's the benzene. So we have benzaldehyde here. We don't have to give a number for the aldehyde, but we do need a number for the other substituents, which are chloro. So we start with the aldehyde as being 1, 2, 3, 4. So 3, 4, because that's where the chlorines are, dichloro, benzaldehyde. Pentanal, because there's 5. Benzaldehyde, because it's benzene with an aldehyde. 2-methyl, because it's on, we start counting at the oxygen. 1, 2. 3, 4 dichloro, because we start counting at the aldehyde. 1, 2, 3, 4. Here are some aldehydes that you might be somewhat familiar with. Vanillin, giving us our flavoring for vanilla. Cinnamonaldehyde is the aroma that comes with cinnamon. Here's the aldehyde right here. There's some other functional groups in here too, just to point out. OH is alcohol. OCH3, that's going to be an ether because it has a carbon on either side of the oxygen. And then we have an alkene here. Now, one thing you might want to keep in mind, this is an aldehyde. You'll also see abbreviated CHO. That means the exact same thing. Now we're moving on to ketones. We're going to replace that E at the end, and we're going to replace it with O and E. Remember, IUPAC is the systematic names, which means that this is what we're used to seeing. So for ketone, they end in -one. There are a couple with common names, and that's referring to if we have, this is the carbonyl, it's looking at what's on either side of that carbonyl. So there's a methyl here and a methyl here, dimethyl ketone. There's a methyl here and an ethyl here, alphabetical, ethyl, methyl, ketone. So they look at these as if it's a substituent coming off of the carbonyl. So these are the common ones in parentheses. The systematic name, the IUPAC, is on top, and it's just like what we've used to seeing. There's 3 carbons, which is propane. We take off that E and put O-N-E instead, so it's propanone. 1, 2, 3, 4 carbons. That's butane. We ended in -one. Now notice, for the propane, you didn't bother putting a number, but on the butane, we did. The reason is, if we're looking at a ketone has to be surrounded by hydrogens, or by carbons, pardon. Ketone has to be surrounded by carbons. As a result, the only place that you could put an oxygen that's surrounded by carbons is the middle carbon. So we didn't have to say 2-propanone because it's already given. Whereas for butane, it could have been here or it could have been here. But it had to be in the middle, so you have to say where it is. So it's only propanone you don't have to actually say where the oxygen is. All the other ones you do. So first thing we want to do is find the longest chain. 1, 2, 3, 4, 5, 6. That's hexane. We're going to change that E to O-N-E. So it becomes hexanone. For ketones, we do have to say where the double bond is, unlike aldehydes. Aldehydes is a given, that's the beginning. But with the ketones, it could be anywhere in the middle, so we have to say where it is. You start counting that's closest to the oxygen. 1, 2. So on the second carbon, there's a ketone of hexanone. We have one thing that's not accounted for, and that's methyl. So 1, 2, 3, 4. 4 methyl, 2 hexanone. Alright, for the next one, we have cyclopentane here. That E drops, becomes O-N-E, cyclopentanone. Now for cyclic ones, you typically don't have to say where the double bond is, because that's where we're going to start counting. So I'm not going to put one cyclonone. It's going to be given that cyclopentanone is on the oxygen's on the first carbon. However, we do have to say the other two groups, which are methyls. So 2, 3 dimethyl. So first, hex, because there's 6. O-N-E, because the oxygen's in the middle. Cyclopentane, double bonded oxygen, cyclopentanone, is on the second carbon. This one, don't bother putting a number, because it's a cyclo. On the fourth carbon, 1, 2, 3, 4, there's a methyl group. On the second and third carbons, there's methyl groups. So just some ketones that you might be familiar with. Acetone is the most familiar one to a lot of people, and that is paint thinner or nail polish remover. Notice 3 carbons, it's on the middle carbon because on either side has to be carbons. Butane dione, they put di in there because of the fact that there's 2 oxygens. But but because there's 4 carbons. Alright, so first of all, let's see if we can identify if it's an aldehyde or ketone. Remember, if it's at the end, it's an aldehyde. If it's in the middle, it's a ketone. An aldehyde has to have a hydrogen bonded to it. So this one is in the middle, so it's a ketone. This one has a hydrogen on it, and it's at the end. It's an aldehyde. This one has a hydrogen on it. And this one is surrounded by carbon, so that's a ketone. There you go. Alright, so now we're going to combine with everything we've learned so far this chapter. This one's surrounded by carbon. There's no hydrogens on that carbonyl, so that's a ketone. This oxygen is in a double bond. It's surrounded by carbons. That's an ether. This one does have a hydrogen bonded. That's an aldehyde. And we have an OH group. That's an alcohol. Alright, so now we're naming these ketones. Find the longest chain. 1, 2, 3, 4, 5, 6. That's hexane. But because it's a ketone, it's hexanone. And we have to say where it is. It's on the second carbon. There are no other substituents here, so we're done. Here's our longest chain here. That's butane. It becomes butanone. Once again, it's on the second carbon. We do have another substituent here, and that's chloro. So 1, 2, 3, on the 4th carbon, there's a chloro. So 4 chloro, 2 butanone. First, name them, pentanone and butanone. Figure out where those oxygens are on the 2nd carbon. And then find the rest of the substituents. So, naming the aldehydes again. We have 4 carbons there. That brings us to butane. It's an aldehyde, so butanol. I don't have to say where the double bonded oxygen is, because it's already assumed that's at the end. This is another but, because there's 4 carbons. So butane becomes butanol. We have 2 methyl groups. 1, 2, 3. So it's on the 3rd carbon. 3, 3, dimethyl butanol. Butanol and butanol. The second one has substituents, so we have to say 3, 3, dimethyl butanol. Alright, and we are going to draw the structures of all of these. Pent, which means we have 5 carbons in a row, is an aldehyde, so the very last one has an oxygen. And on the 4th carbon, 1, 2, 3, 4, there's a methyl group. And all the rest of these have hydrogens. Prop, which means we have 3 carbons, is an Al, which means there's an aldehyde at the end. 2, 3, 1, 2, 3, dichloro. So we have 2 chlorines. All the rest of them are hydrogens. And the last one, butanone, that means we have a ketone here rather than an aldehyde. 4 on the 2nd carbon, 1, 2, there's a double bonded oxygen, and on the 3rd carbon, 1, 2, 3, there's a CH3. All the rest of these are hydrogens. Remember, each carbon has a total of 4 bonds. Because we have 2 with the oxygens, 1 to this carbon, 1 to this carbon, there is no hydrogen on that one. And there's your answers. And that is all for naming aldehydes and ketones.